Right, back again, Unit 5 Aqueous Chemistry, looking at doing some of the terminology that goes into looking at the solutions that we will be prepping in the lab. So it'll be just some terminology things, how we get them into solutions and some of those things. The next video will deal with the math part of this. So there are a number of different, there's a couple of different ways in which we've talked about solids so far, and that we've talked about the ionic ones, which are normally called salts. And then you also have the polar and nonpolar solids. Usually find those in your molecular, your nonmetal, your covalent compounds, because most of your ionic compounds are going to be a salt of some sort. Now, this can be usually seen in a metal with a nonmetal or something with a polyatomic ion, and so we would also want to have that. And actually, this is how old these notes are. You can actually see it is actually, we don't actually use uh, Unit 4 anymore because we used to look at that. It's actually still earlier or earlier in the unit. And so we don't use Unit 4 anymore. It's the old numbering system. So now you just look at your solubility rules earlier for whether or not it's an ionic compound, whether or not it's even soluble. For covalent compounds that are polar or nonpolar, we use the like dissolves like, and that's why at the end of the unit that we looked at in Unit 3.5, we talked about being able to identify polar or nonpolar molecules. And polar solids will dissolve in polar liquids, and that's why certain of them will dissolve in water, because water is a polar compound as well. And nonpolar will only dissolve in nonpolar liquids. And that's kind of like the why does the grease not come off your hands with water very easily? That's because it's a nonpolar solid, usually the grease or liquid of some sort that gets stuck under your hands and it doesn't come off. Or why you have to use certain chemicals on your hands if you get like a glue on your hand or something like that. Some glues are a little bit, they're very harsh. But it all comes down to that like dissolves like rule that we have. So how do we get these solutions into, uh, these solids into solutions actually? There's three different ways because sometimes they don't go into solution very often. Some of these salts don't dissociate very nicely, and so you have to help them out a little bit. One of the most common ones that a lot of you probably have done before, and that is stirring or agitation. Stirring your Kool-Aid before you are able to drink it is usually a pretty good thing as well, because it helps get the sugar to dissolve in the water, and it also kind of gives those dyes and things like that to go into solution as well. The temperature, increasing the temperature is usually going to also increase the solubility that it will have. It's because really it comes down to is the if you increase the temperature of just say like water, what you're going to start seeing is the water molecules would be able to bombard or hit the other molecules a little bit more often, increasing the potential contacts by also looking at decreasing the surface area of the dissolving particles. You also increase their ability to actually dissolve as well. So that will make sure that it will happen, and that will continue to go. Now this does usually take still a little bit of time. Sometimes you have to use all three. You have to crush or use a mortar and pestle to crush your solids a little bit, and then put them into the solution on a stirring hot plate, which we do have a couple of those, and so that you can increase the temperature as the magnetic stirring rod is moving and agitating the solutions. It does help and cut down on some time, but nevertheless, it is something that is important that we do. Now, we have some of these that when it comes to liquids and liquids, in that we have some are miscible or immiscible. Miscible means mixing, so we would look at the miscible solutions allow for the mixing, and immiscible are ones that do not mix. Uh, and so that is part of the part that we can kind of utilize. And you would look at, say, water and vinegar. Water and vinegar do mix, they're miscible. Both of them are polar solutions, but oil and water are immiscible and they do not mix, in that you actually have that layer forming. And you can also do the same thing with, say, an oil, like an olive oil, and your vinegar as well, and that's why you have to mix them up still, and it kind of helps just kind of suspend them for a certain amount of time. If you leave it alone too long, it will actually start separating itself back out. And so we do have some of those that you can kind of get them into a kind of a suspension if you shake it hard enough. If you don't shake it hard enough, and then they separate out, and then you're kind of just getting a lot of oil or a lot of vinegar. So the liquids idea of the like dissolves like is a very important part of that as well. Now, when it comes to there are some exceptions in that water and uh, trichloromethane they are miscible, and because it is slightly polar, and that does happen as well. Um, and you just have these ones, and a lot of it comes down to uh, experience and me telling you, hey, here are some examples. We don't have to worry about any of these in our lab, because what we're actually going to see is that we're going to have the polar molecules are usually going to be water. That's really all we're going to deal with in our lab. And everything is going to, the solutions that we're dealing with are all going to be miscible. Every now and then we might find one that is not, but it's pretty rare here. But for those of you that go on to bigger and better things, it is important to understand that not all solutions, even though it says that it's polar, doesn't mean that they are actually going to mix or are miscible. Some of them are immiscible, and it's just experience. The more you experience, the more science you see and do, the better you'll and better understanding of that is what will help you out. Some terms that we use when it comes to dealing with concentration, and not talking about whether or not you're paying attention, is there are the three ones that we kind of look at, and that is a saturated solution, unsaturated solution, and then a supersaturated solution. Some of these we use a lot, some of them we don't use very much. A saturated solution is when you have the maximum amount of solute in a given temperature, because that can change, and it's going to be something that the temperatures are going to be given to you just to kind of clarify and make sure that you don't get some of those huffy puffy professors that would kind of like to nitpick every single problem out. It's just there for information, and it will make more information later on in a later unit when we actually talk about thermochemistry, and then it kind of just builds upon itself. But you can usually increase the amount of solute if you increase the temperature, as we talked about earlier. But that's just what we'll look at a given temperature. Unsaturated solutions means you just have less. Now, this is not a very good term that we use. Unsaturated solutions are usually not a term that we use very often, because an unsaturated solution could be just a couple grains, just a couple milligrams short of being a saturated solution. Um, so it's not always nice. Very rarely do we use even these two with it. They can be used. But they are useful. We've used some saturated solutions when I needed a saturated salt solution, which basically means we just put as much salt in there as we possibly can, shake it up, hold it and set it there overnight, shake it up some more, and then add even more. An unsaturated solution would be kind of not useful, I guess, but it's a term that we use, and so there we have some of those. And now a supersaturated solution is a solution that you've kind of the sodium acetate is one that you can commonly find in on YouTube doing the demonstration of a solution where you'll pour it. As it's pouring, it'll actually start making and forming a solid, and if you just flick the solution just a little bit, it starts recrystallizing. And how that's actually done is they will increase the temperature of water, and then they will be able to get more sodium acetate into solution. Now, this is also the same premise that rock candy is made, in that you get some water boiling and you get lots and lots and lots and lots of sugar dissolved in the water, and then you take that, and as you cool it, you're able to take some rope or some string and kind of roll it into sugar. And what that sugar that you roll it into does is it gives it that place where it will be able to configure, and it will, or recrystallize onto. It has kind of a seed, so to speak, for it, and that will allow you to grow those rock candy crystals. As much fun as that would be as a lab, it just takes a lot of sugar, and I don't have that much sugar at the house at this time, so we wouldn't be doing that or bring in that much sugar to actually do these. Not only that, we would have to use laboratory equipment in class, so it doesn't work out so well. But I know it's something that a person could do in home. Look on Pinterest, and you should be able to kind of play around with some of that. Some terms that we prefer to use, that we see a little bit more common, and that is what's called concentrated and dilute. Concentrated solution is very similar to that of a saturated solution, in that it's highly concentrated. There's a large amount of stuff there, and a lot of times we will actually put some numbers to these. You've seen some of these numbers in the labs before. They're usually, the next slide kind of gives us more about that. But you've even heard me talk about the concentrated hydrochloric acid, sulfuric acid concentrated, or a lot of times we'll even just shorten it up as just calling it as a con solution or a concentrated solution to help us out with that. A dilute solution is something that has been diluted, usually by a certain amount, and it's there, and that's usually kind of where it is. It's usually what it'll be is it's going to be either concentrated or it will be diluted. Now, a concentration of the solution can determine its strength, so to speak, and we have to be careful about that, because a solution that say sulfuric acid that has a molarity of 12, like kind of like its strength, is not the same as, say, a hydrochloric acid, which has a concentrated solution of that would be about a 12 as well. Sulfuric acid's concentration at its highest strength is 18. And so you have to be careful about whether, what the numbers actually mean, and look at some of the other things with it. But that's, again, some things that we're going to deal with for those that go on to bigger and better things. So these solutions, you're either going to have a concentrated solution or a dilute solution, and how diluted or how concentrated is going to be dependent upon the strength that we deal with. How do we talk about strength? Well, that's with molarity. Molarity is the strength, and you can, based on that strength part of it, and that's molarity. There are other calculations that deal in concentration, molarity, molality, and normality. We're not going to deal with the other two. We're going to deal with molarity. I feel it's the more useful one for the general public of students that we deal with, and that's kind of what we look at. We can look at, say, percentages as well, and it does work, but I think molarity is a nice useful tool, and therefore you just have a very nice, easy moles of solute is equal to the volume in liters. And sometimes what we'll look at and use is saying it's a mole per liter. Now, last unit we talked about the equation essentially of molar mass is grams per mole. Well, this is molarity, and you've seen this big M in the lab before, and that usually has a number in front of it. And so that's what it's dealing with. It's telling us the concentration of how many moles per liter of that. And that we're going to get really good at converting our volume into liters. And we're also going to continue to get good at calculating our number of moles, going from a mass to the number of moles, and we'll have a lab that will also help us understand and do practice some of those calculations as well. And actually, the next video in this will deal more with the calculations specifically. I felt they would be just a little bit too long, adding the calculations after this, after going through all of the kind of the terminology part of it.